All right, I got on the ugly brown shirt again. It must be time for another science video. So, today we are going to work with the distance equation, which we have already been working with before. We're going to work with the distance equation, and today we're going to solve for acceleration. Okay? So what that means is the problem will provide us with a final distance, an initial velocity, and time, and then we just got to do some algebra to solve that. So I want to begin this video repeating something that I said in another video. These are the two equations that we're going to use most often in introductory physics class. We're going to be solving for distance, or we're going to be solving for final velocity. Now, a fine point is this equation, the velocity equation, does not have any distance variables in it. So if you're asked to find distance, or if distance is given as part of the problem, then you cannot use this, or else the distance is extraneous, which is a possibility, but we'll not go into that right now. If you have a final velocity, you cannot use this. This is the only equation with initial and final velocity. Okay. Now we have these other equations that we have down here, where we have had. These are the kind of the odd, random, occasional equations. These are the main two. Okay. So in this video, we're going to be solving for A. All right. Step one in solving any science problem is to write down what is given. So we're going to contrive some numbers. I'm going to say that the final distance, meters per second, and we will say that the rate of acceleration is 5 meters per second. 1, 2, 3, 4 of the variables. And the question will say, what is the rate of acceleration? All right, now what does this look after? This is t. Two for two. All right, let's make up a problem and see if we can solve it. Remember, we're going to be solving for acceleration, right? So we're going to be solving for acceleration. So that means that A is the question. Now, the way that's going to look in a problem, it's going to be lots and lots of words. What is the acceleration when? Or we may say, what rate of acceleration is required in order to accomplish blah, 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 a lot of stuff. Okay? So, what is that lot of stuff? And it could be rockets in space, it could be drag racers in the desert, it could be who knows what. But let's say it says somewhere along the way that the final distance is 200. So something happens and accelerates, and then it ends up 200. Let's say it started with an initial distance of 50 meters. And let's say that it began with an initial velocity of 20 meters per second, and that the time is 4 seconds. So now we have our variables. We have written our variables down. And again, the question is going to begin. It's going to say something to the effect of, what is the acceleration required in order to, after 4 seconds, place a rocket 200 meters from the space station if it had an initial velocity of 20 and was initially 50 meters from the space station? Something like that. Okay? Extracting the data, extracting the numbers from the problem. I understand this is one of the hardest parts for introductory students. You just have to work through it enough and do it enough times that you can work it out. The second step, and this is the one many students want to skip and resist, that is to write the equation. We've already looked at the equation, so we know what the equation we're going to use is going to be d sub f equals di plus vit plus 1/2 a t squared. So df is, now we're ready to plug our numbers in. Omitting the step of writing this equation ultimately proves to be a mistake. Ultimately, you might be able to get away with it sometimes, but the best thing to do is to continuously use the same steps of writing it down, plugging in, and solving. That way, when something gets a little tricky later on, you have the muscle memory of where you put the equal sign and where you put the variables and all that sort of stuff. So I'm going to color code this because I have they're not Sharpies, they're highlighters. I don't know what's wrong with me. A is what we're looking for, the question mark. So there's purple. D sub f is 200, and it's going to go there. Okay? D sub I is 50. D sub I is going to go there. VI is 20. VI is going to go there, and I made my circle too big. T is 4. T goes here and here. It's going to be t squared. So now we're ready to plug our numbers in. So I'm going to take the 200. 200 meters equals di is 50. 50 meters plus VI is 20 meters per second times 4 seconds plus, then I'm going to have 1/2 a, and then I'm going to have 4 squared. Now this throws people off by having written the a in the middle. I kept the a in the middle because that's where it is in our equation, but we're not used to seeing the unknown variable in the middle. I could have written 1/2 times 4 squared times a and reordered it, because multiplication, it doesn't matter what order we do it in. We can multiply this times this times this, or this times this times this. What we cannot do is multiply before we clear the exponent. So the next thing we're going to do is we're going to clear the exponent. 4 squared is 16. 16 times 1/2 is 8. And I'm going to write that as 8a. And the units on this is going to be second squared. Okay, so that's the units on the 8. Now I've got 20 times 4. 20 times 4 is 80. The seconds are going to cancel with the seconds, and that's going to leave us with meters. So 20 times 4 is 80 meters. I got lucky there. Now I got 50 meters. That's coming down. 200 meters. I need to combine like terms. Meters, meters, meters. So I'm going to combine these. That's going to be 130. 200 meters equals 130 meters plus 8 seconds squared times a. Still got the a here. Subtract 130 from both sides. I know a lot of my students like to actually do this. Actually, they would do it there. So subtracting 130 from both sides leaves us with 8 seconds squared times a. And over here, 70. 70 meters equals 8 seconds squared divided by a times a. Now we divide. We're going to divide both sides by 8 seconds squared. That's going to cancel, leaving us with a equals So 8 seconds squared cancels, leaves us with A. 70 divided by 8, I don't know what that's going to be, but I know I'm going to end up with meters over second squared. So I'm going to go ahead and write my units in. Now, what are the units on acceleration? Meters per second squared. By keeping up with our units, we have proven, at least, that we have followed the right steps. And let's see if we get the right arithmetic. Clear? 70 divided by 8 equals 8.75. 8.75 meters per second squared is A. All right. That's how you go through the algebra to solve this. So you're going to plug in your numbers, start with the exponent, clear that out. That's going to get us down to here. So we have this 8 thing. This is the thing we're solving for, is A. These are like terms. Combine them and do the subtraction thing. Okay, some people want to do it. They could say 200 minus 50 equals 150. 150 minus 80 is, you can get to the 70 two different ways. We did it all in one step. And then we're going to divide both sides by the 8 seconds squared, and that's going to give us meters per second squared, and 8.75 is A. I cannot reiterate enough. I cannot say it enough times. I cannot say it enough times. I cannot say it enough times. You must write down what's given. You know where this is going. Write down the equation, plug in, and solve. I had a guy in class today. He did this. He wrote down his stuff. He plugged in and solved. He wrote down his stuff. He plugged in and solved. Made eye contact with me a few minutes later, and he said, "I understand it." Before he had been writing down and plugging in, didn't understand it. But by visualizing at this step here, you plug in these numbers that you got out of the paragraph, plug this in, and solve. Plenty of video to go on acceleration. 10 minutes to do a very simple algebra problem because I talk too much. So thank you for watching. I will not talk anymore except to say thanks for watching. If you enjoyed this video, hit the like button. Subscribe to the channel for more science videos and the other stuff I do. And we'll see you in the next video. I don't have a drone or an electric-powered skateboard, but I do have a drawer full of Sharpies, all different colors, and highlighters, and gel pens, and a calculator. I'm Bill Snodgrass. You should subscribe to my channel.